All right, so moving right along here, we've already discussed the differences between alkenes, alkynes, and the alkanes we learned about in the previous chapter. We've looked at some cis-trans isomers of alkenes. We've looked at some reactions, in particular addition reactions that alkenes and alkynes can undergo. And so we're ready to look at a little more of the chemistry of alkenes in particular here. In this lecture, we will specifically discuss some polymers of alkenes, and we'll take a look at polymers in general. Polymers are obviously a very important part of modern life. They have been for decades now, and we'll take a look at what these poly substances, polyethylene, polypropylene, whatever else you might see in use and hopefully be recycling after your use. We'll see how they're made and how to identify those monomers and how to find the polymers that the monomers will make. All right, so before we move forward, let's define polymers. Polymers are large molecules, sometimes known as macromolecules, that consist of small repeating units called monomers. And that will actually end the whole course with nucleic acids, which are natural polymers. They are found in nature, including cellulose in plants, starches in food, proteins, and then DNA, the nucleic acid that I just mentioned, being DNA here in this case, one of our critical nucleic acids in the human body. Polymers can also be made synthetically, such as polyethylene and polystyrene, Teflon, which is a perfluorinated polymer, and then nylon is another example of a synthetic polymer. They're often made by reaction of small alkenes at high temperature and pressure, and actually Teflon was discovered by accident. There was a chemist who had ordered a cylinder of the precursor gas that actually makes Teflon, and when he went to use his cylinder of gas, nothing came out. And being a scientist, he needed to know why, so he sliced open that tank under appropriate safety precautions and found that it had all been coated by this very slick polymer that, again, has become ubiquitous with the idea of non-stick. If you've used, Teflon coated pans or Teflon for any other particular application, it has a very slick surface, and it was, like many important discoveries, discovered by accident. Okay, so if the polymers are those long chains, well, polymerization is the process where those small repeating units known as monomers join together to form that long polymer chain. So we see here ethene, or as it's more commonly known, ethylene monomers joining together to form polyethylene or polyethene. You'll never see it referred to that way, unfortunately, because the common name ethylene is so much more prevalent, and therefore the polymer known as polyethylene is much almost exclusively the way you'll see it. I've never seen polyethylene, although as chemists who obey IUPAC, we should want to see polyethylene, but it's a losing battle, unfortunately. Maybe in the next generation you'll win that battle. Notice we have the monomer unit there sectioned off by brackets, and then many. We can't really put a number. Sometimes these things are hundreds of thousands of repeat units. Sometimes they're millions of repeat units. It's just a very, very large number, so we don't ordinarily specify with a specific number. In this slide, we just see a number of different common synthetic polymers. So there's that polyethylene that we talked about, and it's usually a free radical initiation. Somebody just steals an electron from a neighbor, and that goes on down the line and propagates, and that's how we typically get these monomers to react to form the polymers for something like polyethylene. Polyvinyl chloride is another very, very common substance. You'll see it in anything that's referred to simply as vinyl. It's almost always referring to polyvinyl chloride as the polymer. Polypropylene is finding applications in many different areas, even clothing as we see here. Polytetrafluoroethylene is the actual chemical name for the trademarked name of Teflon, and we see those Teflon coated cooking and baking implements there. Polydichloroethylene, which is saran wrap by trademark, is again a similar to our polyvinyl chloride. It has chloro groups, and that's why a lot of people are cautious about microwaving it or exposing it to too high of temperatures, but it does seem to do a nice job, at least at room temperature or in the fridge, at keeping foods fresh. And then finally, polystyrene is our polymer that can take on lots and lots of air and form these foams like styrofoam in the cups that we see there. So a couple slides ago, we looked at polymerization of ethene or ethylene to form polyethylene, and that's commonly used in plastic bottles or films or insulation materials. And you hopefully are recycling that one. That one is commonly either polyethylene itself or polyethylene terephthalate is often used for recyclable end uses, and hopefully you're keeping that recycling going after you use that substance. Then we have chloroethene, which is the IUPAC name, and of course, since it's an IUPAC name, we very rarely see it in the real world. That's commonly known as vinyl chloride, so that when it becomes the polymer, that's polyvinyl chloride, or PVC as it's more commonly known, and that's used for plastic pipes and tubing, right? A lot of sanitary pipes that may have been lead or copper in the old days are now these plastic polyvinyl chloride or PVC pipes. Garden hoses, garbage bags, very common applications of vinyl siding, lots and lots of different applications for PVC. Then finally we have propylene, or propene as we should call it, but we don't see that anywhere. It's polypropylene based on its old common name instead of polypropene as we should really call it. And that's used in skiing and hiking clothing. It's good at keeping the wind and the water out, so it's wonderful for those applications. It's also used in carpets, and even artificial joints are often coated in polypropylene. So lots and lots of applications for just a few of the many polymers out there. Continuing here with table 12.3, we see tetrafluoroethene. That was the gas that our chemist, whose name escapes me, had ordered a cylinder back several decades ago now, and when he went to turn it on, nothing happened because it had all polymerized to our polytetrafluoroethylene, or Teflon. And again, that's commonly used in nonstick coatings and nonstick tapes. Teflon tapes are used in plumbing a lot, and obviously the cookware applications that we saw before. If we look at and I mentioned before that Teflon discovery was a coincidence, an accident, whatever you want to call it. In science, we tend to call it a serendipity. That's a little nicer than saying it's an accidental discovery. It's a serendipitous discovery, and then the public doesn't really understand that we didn't know what we were doing and we just lucked out. That's not true. Luck, chance favors the prepared mind, right? That's, I believe, Pasteur said that. If we move on to our table, 1,1-dichloroethene. Now that's polydichloroethylene, and that's the saran wrap that we looked at before. Plastic film and wrap is the major application. And finally, phenylethene, or styrene, as it's more commonly known, gives us our polystyrene, which is commonly used for styrofoam cups and cartons or insulation. And because it can form those foams, that's why it's such a good insulating material, and it's commonly used for home insulation because it does a great job with all the air that it traps inside of keeping the interior home warm in the winter and cool in the summer compared with the outside temperatures. All right, so now that we've seen a number of polymers, let's do a learning check here and see how well you're understanding this concept. In this learning check, you're asked, what is the starting monomer for polyethylene? So looking at that final structure, what does the beginning monomer look like? So pause the video here, draw that monomer, and start us back up when you're ready to check your work. Okay, and there it is, ethene or ethylene. It's got to be at least a 2-carbon substance in order to have that double bond that makes it reactive, and in this case it's the simplest monomer we can have, just a carbon-carbon double bond with hydrogens completing the bonding on each of those carbons. So ethene or ethylene, our simplest monomer, and gives rise to our simplest polymer here, polyethylene. If you weren't able to identify this one, take a look back several slides ago, see where we looked at the reaction of ethene, or ethylene as it's commonly known, to form polyethylene, and certainly reach out to me if you're still struggling with how to identify these monomers. Okay, here's a follow-up learning check for those of you who are feeling very comfortable with this concept of polymers and monomers. In this learning check, you're asked to name the monomer used to make Teflon. So you may need to flip back there to chapter 12, the table 12.3 that we were talking through earlier, and then use 4 monomers. So draw 4 monomers, one plus the other plus the other plus the other, to draw the condensed structural formula of a portion of the Teflon polymer. So pause the video here while you do that. Start us back up when you're ready to check your work. Okay, so there it is. Tetrafluoroethene is the monomer that we use. And if you took 4 of those and combine them together with just a dash at the beginning and the end to indicate that it goes on and on for many, many more species, well, 4 of those should give you a total of 8 carbons. And we see here, if we start at the left, we have 1, 2, 3, 4, 5, 6, 7, 8. And then finally, because it's just carbons and fluorines present, we have all of those carbons either bonding to other carbons or bonding to fluorines to complete their 4 bonds, their stable octet. So there you have it. If you missed this one, my guess is you probably just didn't understand the directions. And as long as you see where we went with it, I think that's fine. If that wasn't the problem, if you're really struggling with this, please do reach out for some help. Okay, recycling plastics. I've already mentioned a couple of times, I think, that you should be ideally using recycled plastics and then recycling them. And recycling for plastics is simplified by those codes found on plastic items. Now, the code identifies the plastic, and unfortunately, not everybody knows that. One time I was on a bus trip with my wife, and we were sitting behind an elderly set of females, and they were discussing the bottled water, and the one was telling the other that the number tells you how many times it's been recycled. So you want to have a low number, like a number 1, because you don't want to be drinking out of a bottle that's been recycled already and used by other people. I tried to intervene. As a chemist, it's tough to be out there in the public, and maybe that's why we have the stereotypes we do. But my wife shot me the look. She's also a chemist, so she knew exactly what I was going to do, and she shot me a look and said, "We're on vacation." And so I let it drop. But obviously, the fact that I'm sharing that story with you lets you know it still bothers me to this day, and I hate to let those misconceptions continue, but I don't know how receptive these women would have been should I have intervened as I would have liked to. But now you can go out there and you can intervene for me. You'll be much better ambassadors for chemistry than I could be, and you can let people know if you ever hear that misconception that no, indeed, those numbers identify the type of plastic. So here in Broome County, we do a great job with recycling as long as people actually recycle, but we accept a number of different numbers here. And number 1, polyethylene terephthalate. Number 2, high density polyethylene. 3, PVC. And that's polyvinyl chloride, as we said before. Number 4, you might think that the 2 polyethylenes would have been closer together, but this is the way it was determined. So low density polyethylene is number 4. Number 5, abbreviated as PP, is polypropylene. Number 6 is polystyrene. That one I don't think we do too much with, at least not so far in most areas. And then 7, other, typically are not recycled unless you have large quantity and happen to know what it is and can find someone who's willing to recycle it. So we can recycle these. Obviously, that's the right thing to do. A number of them come from sources that are fossil fuel sources, so that is a scarce resource that we're not producing at the same rate as we're consuming. So anything we can do to help the longevity of these plastics is a good thing, in my opinion. Okay, so because it bothers me so much, we'll have one last learning check, and you'll tell me what those codes really stand for. I would never give you just the numbers. As you see here, you get the numbers and the abbreviation. So if you can just go ahead and tell me what that abbreviation really stands for. The common name is fine here, although I'd love the IUPAC name if you know it. So pause the video here while you make those determinations and start us back up when you're ready to check your work. Okay, so there you have it. PVC, which happens to be number 3, is good old polyvinyl chloride. Letter B, number 5, which is PP for short, is polypropylene. And then number 6, PS for short, is polystyrene. So hopefully you've been able to get those down in the little bit of time we spent. And as I said, it's unlikely you'd be asked about these specifically on an exam, but certainly if I were to ask, I would give you not just the number, but also the letter abbreviation. So that should make your job relatively straightforward, I hope. All right, so there you have it. We're done with our discussion of polymers, and hopefully you're knowing more about your polymers and going out and spreading that knowledge to get rid of those bad misconceptions that unfortunately are out there. We'll see you in the next part of Chapter 12.